So, you just got your first sweet software developer job. Congratulations. All that hard, grueling, time-consuming, and heart-palpitating interviewing and job search has finally paid off. On that fateful day, you open your email to find yourself a new shiny job offer. As you bask in the ecstasy and euphoria of your newfound job, you decide to take a walk to think about what just happened. You think about the free sodas. You think about shipping software that will affect millions. You think about collaborating with other team members. You think about the lunches on the job. You think about the new stacks and languages you'll learn. And most of all, you'll think about that sweet dough. Well, guess what? This isn't some kind of adult playground or utopia. No, this is the harsh, cruel world we live in. Your fellow developers have to wrestle with ferocious bugs, developer-eating spaghetti monsters, terrible code bases, bad managers, survival-level tribal code reviews, and other horrors. You need to be strong, you need to be brave, you need to be prepared. Just as you wouldn't go on an expedition without a survival kit, a junior developer needs to be prepared for any situation a project may bring forth. What you need is a survival kit. Okay, enough with the pleasantries. In reality, I really do enjoy being a software developer. But seriously, it's important to be equipped with knowledge that could seriously improve the quality and maintainability of a software system. In these videos, I hope to fill in the gaps of knowledge a junior developer should have to better advance their career and, maybe, even have some fun. Also, I hope these videos are entertaining and fun. If you find these videos annoying, well, take this moment to sit down, relax, and meditate on why such trifle things in life so easily provokes your heart. Now, buckle up your seatbelt and close your tray. It's time for takeoff. If you have been around the software development community for any length of time, you may have heard this term before: dependency injection. Dependency wubbity-bubbity-bub, you may be thinking? Yes. When I first heard this term back when .NET Core was being released, Microsoft was throwing this term left, right, up, down, and sideways. As a new developer, I was so confused. The word dependency injection just sounds something right out of a science fiction film. Although dependency injection sounds like a big word, it's actually a very useful technique in software development that, once understood and mastered, will help make your software more modular, readable, and reusable. So, let's break down the word dependency injection into two parts: dependency and injection. A dependency refers to the tight dependence between two components of a software system. These components could be classes, variables, functions, modules, and even entire libraries. Think of dependency in the real world. We, humans, a subcomponent of the cosmic system, are dependent on other components. We need water, air, and food to survive. In addition, we need other processes of the world to function properly, too, such as temperature, cellular respiration, mitosis, meiosis, and photosynthesis. Wait, photosynthesis? But we aren't plants. Well, yes, you're correct, you smart potato. However, we still depend on plants who do perform photosynthesis. If you were to remove one of these dependencies from our lives, well, you know what would happen. The important takeaway about a dependency is that they introduce what's known as coupling between components. Imagine this. You decide to create a to-do application in Java. You, who want to build a scalable software, decide to add a database. And, oh boy, we'll be covering databases in another video. You heard that Hibernate is a cool ORM, Object Relational Mapper, for Java, so you decide to install it. After reading the documentation and parsing out strange exception messages, you finally get it working properly. You feel so happy about yourself and decide to take a break. Well, the next day, Hibernate was hacked and you decide to remove it and replace it with standard JDBC. But, oh wait, to remove Hibernate would require rewriting your entire app because each major class depends on Hibernate. Now, just looking at this example, just changing a single component of the system can have a butterfly effect in which everything else breaks. So, we discussed what a dependency means, but what is this injection part? Instead of a class declaring and instantiating all of its dependencies, dependency injection states that all dependencies are provided for the class by a different class, most often the class who instantiated this aforementioned class. For example, if class A depended on class logger, instead of creating a new instance of logger, the instance is injected into class A instead. There are many ways of performing dependency injection. However, for most object-oriented programming languages, we usually perform constructor injection, which is basically the idea that we inject all the dependencies through the constructor. There are other ways of injecting dependencies, such as property injection and method injection. Property injection is where the dependency is declared as a property or field of a class, but it is instantiated by a different class. Method injection is where the dependency is declared as a parameter of a method, and the caller of the method provides the instance of the dependency. Alrighty, I believe that covers the most fundamental parts of dependency injection. With that said, I think it's time to have some fun. Let's have a quiz. I will ask you a series of questions, and you'll need to choose the correct choice. Some questions will be straightforward. Others will require a little imagination. Now, I won't be able to tell if you answered the questions or not, so behave. And with that said, let's go. Question 1. True or false? Tight coupling between software components makes software systems easy to manage and test because the developer knows immediately what dependencies each component requires. Is it A, true, or B, false? Alrighty, the correct answer is false. If you answer true, go rewatch the beginning part of the video. Alrighty, next question. Question 2. Which of the following methods can be used for dependency injection? Is it A, constructor injection, B, method injection, C, property injection, or D, all of them? The correct answer is D. All three are valid ways to do dependency injection. Next question. Question 3. Dependency injection is the best way to program. Is it A, it is certain, B, never, C, apply hazy, try again, or D, don't count on it? Well, the correct answer is D. A isn't correct because dependency injection is not the best way to program in certain applications. B isn't correct because it skews too much to the negative. C is incorrect because it isn't a legit answer. D is the only correct answer because you can't rely on the fact that DI is the best way to program. Well, if you got 3 out of 3, congratulations. If not, that's okay. In any case, let's proceed. The reason why constructor injection is beneficial is that it further subdivides your app into smaller modular chunks. If you were to look at a class like logger, what do you think are its dependencies? Could you swap out those dependencies? Without dependency injection, the logger class would be a giant blob of file system dependencies, connection to databases, handles to configuration files, you name it. But with dependency injection, the caller, and you, will have a much more clear view of what components are required for a logger to work. And with that, you will be able to swap out those components without affecting the underlying implementation of a logger. Now, for statically typed languages, that is, it wouldn't be beneficial to just inject a concrete class like console logger, file stream, or cheeseburger as a dependency because you wouldn't be able to swap it out later until you inherit it. This covers a subject known as abstraction, which is an entire beast unto itself. But for dependency injection to work at its finest point, the class who is being injected doesn't care about how a dependency works, but that it can produce the result it seeks. It is up to the developer to design their systems in such a way that if a class implements some kind of interface, whether that's through traits, interfaces, inheritance, or some other abstraction mechanism, all other dependent classes can be sure the class will fulfill its end of the bargain. Another benefit of dependency injection is, if done throughout the whole application, provides a single hub where the application is glued together. If you were to move all of your dependencies to the constructor for each class of your application, you would notice that eventually all your dependencies would bubble up to the top, i.e., the main function. This is due to dependency injection being a way to perform inversion of control. I will have another video explaining inversion of control in greater details, but for the scope of this video, the dependencies would naturally bubble up. This single point where the dependencies bubble up is called the composition root. It is at this place where it is trivially simple to swap out pieces of your app. Hate that logger library? Just subclass or implement some interface and swap it out in the composition root. You're done. The composition root is the command center, the cockpit, the control room of your app. And, as I said before, this makes it very easy to see the overall structure of your dependencies. Now, these two previous benefits all culminate in making code reusable, modular, and testable. Because all the dependencies a component requires are explicitly injected by someone else, we can more easily perform unit testing without relying on dependencies that causes unintentional side effects, like writing to the database. With the power of abstraction, if we fulfill the requirements of the abstraction, our code doesn't care about what it does. With this knowledge, we could stub out fake database connections and provide mocks for implementations that would otherwise cause serious overhead and unpredictability. We haven't really discussed unit testing much, but generally, a unit test tests the most fundamental functionalities of each class or component in the system. They need to be fast, repeatable, and doesn't cause any side effects. This is because unit tests are ran on continuous integration and deployment pipelines many times throughout the day. We wouldn't want to be opening files or databases all day. We will talk more about unit testing in a future video. Okay, We talked about why you may choose to use dependency injection, but when isn't it appropriate or desirable? The biggest drawback is that dependency injection increases overall complexity of your application. Because object graphs can become rather large and some objects require the same dependencies as its parents, manually constructing an object graph from the composition root can be verbose and error-prone. Now, developers have figured out a way to streamline this process by developing something called an inversion of control container, or DI container. Fundamentally, a container stores all your dependencies and will automatically instantiate said dependencies on the fly. All the programmer needs to do is register the dependencies into the container. This video, however, won't go into IOC containers in depth because a short quip about them wouldn't do justice. Just know that using an IOC container will add complexity to your app, as the container needs to handle registering, instantiating, and destroying dependencies. If you don't register a dependency properly or the container fails to load them, the entire application may fail to run. The second drawback of dependency injection is sort of a two-edged sword. DI encourages breaking your application into smaller, more abstract pieces. This allows your application to be more easily swappable, but at the cost of cohesion and directness. If a class requires a console logger, for example, you are immediately notified that this class depends on a console logger. If you wanted, for example, to navigate to the console logger, you can just use your IDE's Navigate to Reference feature. But with dependency injection, the system is less direct about what a dependency truly is. For statically typed OO languages, these dependencies will usually hide in an interface or abstract class. You, the developer, will have to do a little bit more work determining what the underlying dependency is. This is part of the reason why frameworks that have inversion of control and DI at its core architecture are very complicated. DI encourages abstraction, which makes your system more modular, but at the expense of directness and cohesion. These are some of the drawbacks of using DI. Now, I'm sure that there are many more. At the end of the day, though, DI is a great tool in a developer's toolbox. Now, you might be asking me, but when is DI a great choice? The answer is somewhat vague. The short answer is, it depends. The longer answer is that when a system you are building are depending on many external resources, like file systems, databases, web APIs, or external resources, and these dependencies are shared across the entire system, dependency injection and inversion of control is a great way to centrally manage these dependencies. If your team encourages unit testing, dependency injection is the most common way of abstracting away effectful code, i.e., code that creates side effects like network calls. Lastly, if your framework already has a container set up for you, using that container will save you a heck a lot of time and heartache. Don't fight with your framework. Work with it. As an avid swimmer, the worst thing you can do is fight against the current. And with that, thank you so much for watching. If you enjoyed this video, or didn't, please like the video and subscribe. If you don't, shame on you. I will see you next time, if I don't get run over by a bus or a mad giraffe. Bye!